And right now I'm sitting at the flight engineers panel in a 727 because we're going to talk a little bit about AC power generation. Aircraft are a little bit different than AC power that you might see in your house, but it all is fundamentally the same. A couple things to note when we talk about AC power generation. There's really four areas we want to look at. We're looking at voltage being produced, the amount of current, frequency, and phase sequence. These are two additional things that we talk about because AC reverses polarity. It goes positive and then negative. We can use AC pretty effectively because it can run at a higher voltage, which means we don't need as much current to transmit over long distances. That means we can have smaller wires, everything's lighter weight, and it's also very easy to step up and down using transformers. So it is actually pretty advantageous to use. In aircraft, the standard that we use is about 115 volts at 400 cycles, or 400 hertz is the frequency that aircraft are going to operate at. Now, that's an important part to talk about because the thing that dictates how much frequency we're going to operate at, there's a couple factors, but it can either be the number of poles that we have on our generator, but it's also going to be controlled by the speed that the generator rotates at. The faster the generator rotates at, then we're going to have a higher cycle per second. We're going to have a higher frequency. Now, in order to make sure that stays consistent, if we have frequency going up and down with just a single generator, let's say like a DC alternator, not really a big deal because it's the only source of power being generated, and we're only producing power in one direction because of the diodes that rectify it. However, when we have frequency being produced on multiple generators and they're in AC, which means they go positive and negative, then we really need to think about how this is being delivered. If we have two generators that are producing opposing frequency or opposing polarity at the same time, we aren't going to get any power. So those need to be in sequence. So we want to have the phase sequence lined up. When we talk about phase sequence, if we look at that sine curve, right, we have positive down to neutral, down to negative, and then back up to positive. If we have two generators, we want those to be on the same sine wave, so they're synchronized together. We talk about that phase sequence. The thing I like to picture when we talk about paralleling AC generators or tying them in together is like when you're sitting at a stoplight and you have your turn signal on. If you watch long enough for the car in front of you, eventually your two turn signals will synchronize, at least for a little bit. And effectively, that's going to be the same thing. If we have two or three generators that are operating at the same frequency approximately, then we should be able to get those to line up with their phases one by one. And that's part of the job here in the third crewman's panel, is to get those set up. So let's talk a little bit about how that happens. The way that we can control the frequency on these generators is we have to be able to control the speed. And that's a problem because obviously if it's attached directly to the engine can increase power, it can decrease power. It's going to cause us some issues. So in order to make sure that we have a constant frequency, we need to have effectively a transmission between the engine and the generator. We refer to that as a constant speed drive. And what that's going to do is allow us to regulate the speed the generator rotates at, and it's going to allow us to, in some cases, manually adjust the frequency. Like you see right here, we have these frequency knobs we can use to tweak the frequency a little bit forward and back to line it up with the other generators. The other option we have is what we call an IDG, or an integrated drive generator, which is basically a unit where we have the generator and the constant speed drive all as one unit. The whole thing comes off or gets installed on the aircraft as a unit. So we can control our frequency by maintaining the speed of the generators regardless of what power setting the engine's at. Helps us out an awful lot. Now, when we get this all set up, you'll notice we have a few different switches and things we'll see maybe somewhat familiar. Up top, we have our generator drives. This controls our CSDs. We have the option to disconnect in flight if we have a problem, if a drive blows up or something like that, but we cannot reconnect in flight. It's just the way it's going to work. Since those are operating basically as transmissions, we have our drive oil temperature for each of those CSDs. We can tell if it's going to start overheating or anything like that. And then we have our tie-in circuits. Now up here is what we call our bus tie. The bus tie is what connects each generator from each engine onto the main aircraft system. So when the aircraft starts up, initially we have an APU that starts off of direct current. We have a DC power source and a battery stored in the battery belly of the aircraft. That starts our APU. That APU, as you can see right here, will be our initial source of 115 volt, 400 cycle electricity. Now, as we get these engines started up, we're going to switch from the APU over to our main generator. So we would take our first generator, we would end up closing our field, closing the generator, those lights should go out, and then the bus tie we can close and connect it to the bus, and we'll see our kVARs as we put out. So we're measuring the amount of output that we have on that generator. Now, when I move this rotary switch to Gen 1, I'm going to be able to see the frequency that that generator is operating at. I'm going to be able to see the voltage that it's operating at. Now here comes the tricky part. When I want to add on a second generator, I'm going to go through the same process. I'm going to close the field, close the generator, but then the bus tie, I'll switch over and I can start synchronizing with the bus. So if I switch to generator 2 right here, these two lights are going to either slowly pulsate on and off, or they're going to stay on. If I'm completely out of phase, the lights will just stay on. Otherwise, as those phase shifts start to line up, those lights are going to pulsate on and off. When they're off, I can hit my close and I'll connect that generator to the system. Once they're locked on, they'll be synchronized and we don't have an issue. As the generator is operating, if for some reason we had a failure with the system, say that a CSD started to blow up or we had some other issue, as soon as the frequency of a generator drops below a certain threshold, our generator control unit will automatically trip our bus tie, so it'll disconnect that generator from the bus to keep us from losing electrical power. On the flip side, it will also monitor those 4 critical components we talk about. So the generator control unit will be looking at voltage being produced, it'll be looking at current, it'll be looking at frequency, but it'll also be looking at that phase as well to make sure that everything stays aligned and happy. That's the basics behind what we see in a very, very old system like this. Most modern aircraft, especially on large airliners like this, you're going to see it condensed to a very simple panel over on the overhead panel between the pilot and the co-pilot. So it's a little bit different than it used to be, but this is about as ancient as we can get, but it does display pretty nicely how this system works. Another thing to notice, when we talk about these AC generators for large aircraft like this, obviously we have very high power output, and we're also going to be operating at much higher altitude. So as a rule, you're going to tend to see these be brushless AC generators to reduce the amount of arcing potential that we have when it's operating at altitude and inducing failures on the equipment. That's what we got about AC power generation on large aircraft. So anytime you're on a flight and you're enjoying charging your phone or watching the in-flight entertainment, or you like having lights on in the cabin, just remember that there are some AC generators working very, very hard to make that work. And, if you're sitting there and something just seems a little bit off, the lights seem to be flashing at a weird frequency, you get a weird headache, it might just be that our frequency is not operating properly, as we aren't used to seeing those cycles per second. Anyway, now you know it. Hopefully you appreciate it. Thanks for watching.